All right, let's discuss a little bit about what happens when you boot a BBB, BeagleBone Black. So I do have this setup here. Let's see. So I do have this setup here. So this is pretty much the BBB, BeagleBone Black. Very small. You could see by the size of my hands. I wish I have a nickel here or a quarter so you can get a sense of how big it is. Think of it like an Arduino, but this is essentially a small, affordable single board computer. Pretty cool. And think of it like a tiny computer on a single circuit board. And this is one of the neat features about this is it's a system on chip SoC. That this is the AM AM3354. Let me see if I can focus this. But the chip is AM by National Instrument. I can't focus this. Okay, I can't show that on focus, but basically has an Cortex A8 processor. Pretty cool. System on, going back to the system on chip, what that pretty much means is that instead instead of adding whenever you need USB host, HDMI, all the peripherals, instead of adding them as an addition, basically this chip supports all of that. Some of the notable components are the DDR RAM, eMMC, built-in storage. Think of it like an XS, a tiny SSD card. You also have a micro SD card slot here. You could use it to do all kinds of. So micro XD card. I also have a USB host right here. We have one of the regular USB, and we also have console USB right here. We have a HDMI port, which is this little guy right here. Then we have four user LED that you can program, which are right here. Right there, four user LEDs. So to run a Linux on this board, you pretty much need to understand how to wake it up, which is essentially the boot process. Why do we have a boot process? Think of it like starting a big giant car. You can't just go from 0 to 100 miles per hour. You need to start small and continue going. So a typical board like this will require a minimum of four stage boot, which is where my picture here comes in. Let me see if I can extend this. So this is a basic 4-stage booting process that a microcontroller that like this will go through at minimum. Think of it as whenever you power on the board, like plugging in a power supply, or whenever you hit a reset, it does go through these stages of booting. The first one is essentially the ROM booting. So backing out a little bit, BeagleBone Black. This board There's this board right here. It's quite a complex machine that runs Linux, which is uh, at itself super large, complex system. So in order for you to successfully run Linux, you pretty much have to do a bunch of initialization in terms of booting, which the act of booting is quite complex. Even though when you use it, it seems fine. Just think of it as, computer actually booting is initializing all the peripherals, initializing initializing a lot of configuration. It's just a beast. So for it to fully go through those 4 stages, in this everything needs to work together as intended. Starting from the ROM, which is essentially the bootloader. It's built in actually. ROM, unfortunately, think of these 4 stages as 4 separate softwares, essentially. That's actually a good way to put it. 4 separate software. This ROM is cannot be changed. It's basically stamped at the factory, and what it pretty much does is it hands over the booting, the MLO, SPL MLO. And one of the things that it also does is it reads the system boot pin or whatever system pin. So to boot from SD, so you can configure it to boot from the XD card. You could the XD card. You could configure it to boot from the Ethernet. You could configure it to boot from the USB, and you can also configure it to boot from the SPI SPI. So going back to this picture, what this does is it reads what you have configured. The most of the board will have a dip switch that will tell you exactly, that will set up the boot sequence that you wanted to go through. For this BeagleBone, you can do it with a S2 push button right here. So you could change the boot sequence using this particular push button. It's right here. It's called the S2. So pressing it will basically force the board to boot from the micro SD card. So I think I've spent quite a lot of time on this ROM bootloader. Just think of it as one of the things that it does is it decide what boot sequence to go through. It's either going through an eMMC boot, which is essentially an SD card with software in the board itself, or go through a micro SD card. The eMMC is actually faster in terms of booting because it's literally on the board and it doesn't have to do too much to boot. So what happens when you hold this S2 pin, S2, when you hold this S2 button, yep, right there. So what happens when you hold this S2 button is it forces the board to boot from the micro SD card instead of booting from the on-chip SD card. I think that's a good takeaway from this video. So now, after it knows what boot sequence, either booting through the onboard SD card or booting from the external SD card. So as soon as it finds that out, then it goes to the SPL /MLO, the secondary program loader, that's what the SPL is, or the MLO, which is memory loader. So what this does is pretty much initialize the device tree, DDR RAM. So it does initialize that, and it hands it over, it hands off the boot into the U-boot, which is essentially loading the kernel. So U-boot is a quite universal in terms of embedded system. So it's one of those smart assistant that is another software that loads the kernel and hands over all the tasks to a kernel. But some of the things that U-boot would do would be to load and read the configuration, to know where the Linux kernel is stored, load the Linux kernel into the RAM, and set up parameters to pass to the kernel. So very important booting system. And finally, we are at the Linux kernel root file system. Pretty much the last part, which is very important in the sense that it does initialize all the hardware, like the USB, the HDMI, the network cable. It also mounts the root file system. So whenever you plug in a USB or a power supply to the board, just know that things doesn't just happen. It goes through at least 4 stages of booting in order for it to properly boot up and be useful. So that's pretty much all I have for today. Just wanted to go over that. Try to remove some of the magic in terms of booting, and with this knowledge, you'll be more informed in terms of when things are not booting. Then you can start thinking, okay, you know that the ROM comes with the board, so it might not be the ROM. Is it the MLO? Is it the U-boot? Does it have a Linux kernel? So you can start, troubleshooting from there. So that's pretty much all I have, and I hope this was helpful. Subscribe as I discover more about this board. Thank you. Bye bye.